So, this looks an awful lot like your... What did I just... I don't even want to know, do I? I don't want to know? Okay. Hear me right now. Hear me right now. This looks just like your quiz, okay? There is a side that you may use your calculator on, and there is a side that you may not use your calculator on. This, you may not use your calculator on, okay? No calculator. Are you with me? Hey, are you with me? You should hang out with me right now. So this says, use log properties to expand the logs completely, okay? So a log for every piece of the problem. How many logs are we going to have here?
3, 4, 5,
2, right? This is a log. Ooh, that's going to be a log, and that's going to be a log. What is the division telling us? Subtraction. So you have log base 3. Hold on, this pen is a terrible size. Okay, log base 3 of y squared minus log base 3 of x. What else do you have to do? Move that 2 out in front. Now you may do that in one step. I'm just showing you the process, but if you see it in one step, go right ahead. 2 log base 3y minus log base 3x. Final answer. Okay? Okay, when you see a radical, you want to get rid of it. When you see a fraction, you want to get rid of it the other way. So just pay attention to what you have. This one's a radical. How many logs are you going to have here? 2. You have your 3, and you have your rad a, okay? So if you want to, right off the bat, break that into log base what?
10.
10. You don't have to write the 10. Are we adding, subtracting, multiplying, dividing? What's coming next? Adding, because this is multiplication, right? Multiplication gets us addition, the log of the square root of a, but we don't want radicals in the expanded form, okay? You can leave a radical in the non-expanded, not in this. What is another way of writing the square root of a? A to the 1/2. Okay, so you have the log of a to the 1/2. We're going to move that 1/2 out in front. So it's going to be log 3 plus 1/2 log a. That is your expanded form. All right, this one, there's a couple ways you could do this. I personally don't really care which one you choose. Tell me one thing that you would do first. Make 2. Okay, so if you make 2, that 2 has to go in front of both of them, right? Because you're squaring both parts. So you're going to go 2 times the natural log of 5. What operation? Plus 2 times the natural log of x. Okay, so if you're moving that 2 out in front right away, that's fine. I guess that's not moving out right away. That's moving each individual piece. You could also write this as 2 times the natural log of 5 plus the natural log of x, because we would distribute that 2 to both things. I don't care. I kind of like that first one better, but I don't care if you write it the second way. That's fine too. Okay, just make sure that 2 is associated with both parts. So that 2 goes in front for both of them. All right, questions on expanding logs?
We know.
Okay, then, now we're going to shrink it down, a single log. How do I get this to a single log? Move the 4 to an exponent, and this addition is going to be multiplication. So it's going to be log base 5 of what? X to the 4th y. All right, we're multiplying. That's our single log. You try 5. Log 3 minus 4 log b. Subtraction gets you what? Division. Single log. What did you get? But not single log, right? You didn't write. Did you write 2 logs?
Yeah.
1 log, yes. So b, not b. 3 is your numerator divided by b to the 4th. So log 3 over b to the 4th. Okay. The common mistake I see on this one is people write the log of 3 divided by the log of b to the 4th. Don't write 2 logs there, just 1 log, right? We're trying to get it down to a single log on all of those. Okay, here's your natural log, but same process. What do you do? Okay, but single log, so the natural log, it's division. On top, you have an x squared. On bottom, a y to the 5th. And that is your answer. Again, don't put the log on both of them, right? It's 1 log. You're trying to get it down to a single log. Questions on those? Okay. Evaluate. What are you doing when you evaluate? Get a number, right? You should get a number answer for all of these. Evaluate means find the value of, not simplify, right? Not just reduce to a single log. We want the value of it. These ones, you have options. You can do the properties, or you can evaluate each piece and then do the operation. That's totally up to you. I think on this one, I would use the properties, because 4 to what power equals 64 is not a quick one in my head, but maybe it's a very quick one in your head. It's not a hard one. But I would probably on this one set it up as log base 4 of what? 64 divided by 4. And then plug in what is 64 divided by 4. That's log base 4 of 16. Okay, and now that you're here, you say 4 to what power equals 16? What is that? 2. 4 to the 2nd power, right? Be careful with your powers and your multiplying. A lot of people want to tell me 4 here because 4 times 4 is 16. But it's not 4 times 4. It's 4 to what power? 4 times itself, how many times? Okay, so your answer there is 2. If you did it the other way, you could say 4 to what power equals 64? That's 3. Minus 4 to what power equals 4? That's 1. 3 minus 1 is 2. So you can do it like this, or you can do it like this. It's just a matter of what you see. All right, look at 8. What would you do? Multiply. 6 to what power equals 2 is not a nice number. So don't try to figure it out that way. Multiply. This would be log base 6 of 36, right? 2 times 18. And then you're asking yourself the question, 6 to what power equals 36? Don't say 6. 2. 6 to the 2nd power is 36. You try 9. 9's a little foofy.
Yeah.
Anyone got an answer?
I don't know either.
Say it again. Log 1. the 1/2 over 2. I'm trying to think if that converts to the right thing. You should have a number answer. Anyone get a number? -2. Did anyone get -2? Let's see. Okay, so if we take this and make it a power, this is log base 5 of 1 to the 1/2 power. Minus, make this a power, log base 5 of 5 squared. What is 1 to the 1/2 power? What does a 1/2 power do? Square roots, right? So it's the square root of 1. What is the square root of 1? It's 1. So really this is log base 5 of 1, right? 1 to the 1/2 power is the square root of 1, which is 1. Minus, this is log base 5 of 5 squared. I'm just going to leave it like that for now. Hi.
We're just doing a quick tour. I thought I did.
Oh, welcome
Nice and awful.
to Algebra 2.
Algebra 2. Algebra 2. Giving tours. That's all.
Welcome. Okay, who can tell me the value of log base 5 of 1? 0, right? You're saying 5 to what power equals 1? That is 0. Come back to me. Come back. What is the value of this one? 5 to what power equals 5 squared? 2. So this is equal to 0. This is equal to 2. And we are subtracting. 0 minus 2 is -2. Okay? That's how I would do it. You could also do it with division, right? You could do a single log base 5 of 1 over 25, and then you ask yourself the question, 5 to what power equals 1 over 25? 5 to the -2nd power is 1 over 25. So you may do it either way. Pick the one that makes more sense to you. Sorry, did you get that? Can I move on?
Where is how does log 5 1 to the 1/2 go to log 5 1?
Because 1 to the 1/2 power is the square root of 1, right? And the square root of 1 is 1. So just keep simplifying. Okay, number 10. Log base 5 of 1 is what? 0. 5 to the 0 power is 1. So your answer is 0. Those are nice, huh? Those are real nice ones.
What is 1?
Lenny, yeah. There's Lenny. The natural log of E is 1, number 11.
Can that be on the quiz?
I mean, Lenny is on the quiz, yes.
Just that. Is this one?
Just that. Yeah, so the 10 goes out in front, right? 10 times 5 times Lenny, 10 times 5 times 1 is 50. See, isn't Lenny so beautiful? Everybody loves Lenny. What's not to love? Okay, the rest of it, you will get to use your calculator on. This is page 2 of your quiz, right here. Ready? Here you go. Change of base formula. How do you do this? The log of 30 divided by what? Not 5. The log of 5, right? I forgot to ask you if you want to take the quiz. Did you want to take the quiz? Okay. So log 30, parenthesis, make sure you put that parenthesis in, divided by log 5. And you get 2.1133 if we are rounding to 4 decimal places. Just remember that that's a formula, right? Log 30 divided by log 5, change of base formula. That should be the easiest one on there if you just remember the formula. Just got to plug it into your calculator. Okay, solve the exponential equations, round to 3 decimal places. What do you do? Move it out front after we do what?
Put them into logs.
Logs, right? You have to take the log of both sides. So it's the log of 5 to the 2x equals, don't forget to take the log of the 41 also, right? Whatever you do to one side, you have to do to the other. Then move that 2x out in front. So 2x, you may move it in one step. 2x log 5 equals log 41. What do you do next?
Divide by 5,
Log 5. Divide by log 5. Divide by log 5. Here's where parentheses really matter, right? So plug into your calculator. Log 41 parentheses divided by log 5. And you get 2x equals 2.307, we'll call it 4 for now. Okay, and then you're going to divide by 2. So you can just hit divided by 2. You don't have to write the number down. X equals to 3 decimal places, 1.154. What's different about 15? The natural log, right? When there's an E, it's ln, not log, okay? Still a log, but it's the natural log. What do you do first on this one? Before you move it to the front. Divide, right? We have to isolate. So we're going to divide by 7, divide by 7. So e to the 4x equals 4. What do you do next? Now you take the natural log, which is where Lenny's going to show up, right? So you're going to say the natural log of e to the 4x equals the natural log of 4. Move that 4x out in front, so it's 4x times Lenny equals the natural log of 4. Lenny is 1, so just ignore him. And then what do? Divide by 4. Okay, and again, parentheses matter. Natural log of 4, parentheses, divided by 4. So you get x equals 0.347. How you doing? Okay. 16. Now you got to use some properties with this. Can you divide by 2 right now? No, don't divide by 2. Make that an exponent, right? So this is going to be a single log first. So the log of what? X squared divided by, right? Subtraction is going to be division. 3.5 equals 2. So you get your single log. Now how do you set this up? Not multiply by 3.5 because we still got that log there. We got to get rid of the log. How do we get rid of the log?
Divide by log.
Exponential, right? We got to turn this into an exponential function. Remember, inverse. Take the inverse. If we're trying to get rid of a log, the inverse of a log is exponential. So we're going to say 10 to what power?
2.
To the second power equals x squared over 3.5. If you want to make that 100, that's fine. What do you do next? Multiply by 3.5. Okay, so 3.5 times 100, so 350 equals x squared. What do? Take the square root. So x equals, this would come out to plus or minus 18.708, but your answer is only the positive. Why? You can't take the log of a negative number. Okay? 17. What do you do with this one?
10 to the second equals x minus 12.
Right. This is isolated, right? Because of those parentheses, we're taking the log of the whole thing. So this is 10 to the second power equals x minus 12. This one's lovely. So 100 plus 12 is 112. We like those ones, huh?
Oh, that'll work.
Who said that? How did that work?
No, connect the number 19.
Oh, gotcha. Okay, 18. How do you set this one up? What's here?
E.
E. So this is
X plus 2.
e to the fifth power equals x plus 2, right? If you're trying to get rid of the natural log, you got to make it exponential. E to the fifth power equals x plus 2. Take away 2, and you can literally just plug that into your calculator. E to the fifth, arrow over so you get out of the exponent, or hit enter, minus 2. You get e to the fifth minus 2. 146.413. Last one. Want to know a secret? I actually didn't put one of these on your quiz, but it's good practice for when you get to the test. It says a school's population is increasing by 10% each year. If the population is 725 now, when will it be 900? Okay, so this is what you could do as guess and check, but this way's easier now that you know the whole exponential logarithmic thing. I would do it this way, but you don't have to. So the equation, right, this is exponential growth, would be, what comes first? 725, your initial amount. What is your growth factor? It's not 10%.
It's 1 minus.
It's increasing.
Oh, no,
1.1, right? 10% is 0.10, but you have to add a 1 to it. So it's 1.1 to the x power. So that's our equation. They're asking when will it be 900? So we're going to say this. Okay, now treating this like we've been treating all the problems we've been doing right now, what do you do first?
Subtract 725.
Not subtract. Right now we're multiplying. Do the inverse. Divide, right? So you get, what does this come out to? 1.900 divided by 725. 1.2414, we'll call it, equals 1.1 to the x power. What do you do to get that exponent out of the exponent? Take the log. So we're going to take log 1.2414 equals, I'm going to put the x out in front right away, x times log 1.1. And then what? Divide by log 1.1. So still you could do the guess and check, but I think this is easier and you get a more precise answer. So x comes out to, don't forget your parentheses, log 1.2414 divided by log 1.1. Can't read my writing. 2.26, is it 88? So after 2.2688 years, it would be at 900. You made it!